It's your friendly math tutor, Miss C here, and today we are solving quadratic equations. Use the chapters to navigate from problem to problem. We start out easy and we get more challenging in terms of solving the equations. We're starting with x squared plus 5 equals 54. For visualization purposes, we are looking at where the parabola x squared plus 5 intersects with the horizontal line y equals 54. That is what we are finding. So we are going to solve this using the order of operations, and our first goal is to get x squared by itself. So to do that, we are subtracting 5 from both sides. When we do that, we get x squared equals 49. To unsquare something, we take the square root. So the square root is the opposite of squaring, or the inverse operation. When we do that, we get x on the left side. And when I'm the person doing the square rooting, I get a plus or minus here. And that's because quadratics or parabolas are completely symmetrical. So we always get a value that is on the left side of the vertex and a value that's on the right side of the vertex. In this case, the square root of 49 is 7. What this solution means is that this is the value of 54 occurs when x is 7 and when x is negative 7. On to problem 2, same idea. We're trying to get x squared by itself here. So I'm going to do that by adding 12 to both sides. When I do that, I get x squared equals 576. My next step is to take the square root of both sides. Remember, the square root is the opposite of squaring, so that leaves me with x, which is my goal. And when I do that, I end up getting the square root of 576, which is plus or minus 24. That means when x is positive 24, I get 564. And when x is negative 24, I also get an y value of 564. So we should always double check our work. So the way I would do this is I would plug positive 24 in for x and see what I get out. And I'm going to plug negative 24 in for x and see what I get out. When I pop this into my calculator, I in fact get 564. So this answer is, or these two answers are correct. Okay, we are on to a slightly different problem. You're going to notice that everything is enclosed in parentheses and raised to the power of 2. That means our first step has to be square rooting so that we can basically lose the parentheses. So we are going to do the opposite of squaring, which is square rooting. And what we do to one side, we do to the other. That leaves us with x minus 7 equals, I did the square rooting on the right side. That means I'm going to have to do plus or minus 15 here. Okay, there are two ways we can write what we're about to do next. So I can write x equals, I'm going to add 7 on both sides. Some people prefer to write the next step like this. Other people prefer to expand this out to x minus 7 equals 15 and x minus 7 equals negative 15 and solve accordingly. I'm going to go ahead and deal with this equation first. So this is a way you do this with mental math. So we can say 7, and we take the plus 15 as 22. Then we can say 7 minus 15 equals negative 8. Those are our two solutions. If we like a slightly longer way, and I sometimes think this is better depending on whether or not you're great at mental math or you feel more comfortable showing all of your work, we're going to just solve these two equations. When I do that, I get x equals 22. You're going to get the exact same thing. It's just less room for error sometimes when you write everything out. And then I'm going to add 7 on my other equation, and I get negative 8. Now, what these answers mean is that when we plug 22 in for x and when we plug negative 8 in for x, we in fact get out 225. So we could do that and do a quick check. The other way we could think about this is if we look at just this little part of the equation, this tells me that this equation is written in vertex form, right? X minus 7 quantity squared is the vertex form of a quadratic. And what I know is that my vertex has been shifted to the right 7 units. So because quadratics are symmetrical, both of these answers should be exactly the same distance from the vertex. So to go from 7 to negative 8 is 15 units. And that's 15 units left. And to go from 7 to 22 is 15 units, but 15 units to the right. So if we think about this mathematically, we are exactly 15 units in both directions away from the vertex. So that's another way you can check your answer if you don't want to just plug things in. Let's try another one. All right, same idea as the last problem. We're going to start by taking the square root of both sides because we will need to get x plus 9 outside of those parentheses, pardon me. So I'm square rooting both sides. When I do that, I get x plus 9 on this side. Since I'm the one that did the square rooting, I need to add a plus or minus here. And the square root of 484 is 22. At this point, you can break this out into two equations, or you can use a single equation. It's up to you. I'm going to write this as two separate equations. One equal to positive 22 and the second equation equal to negative 22. And I'm just going to go ahead and solve by subtracting 9. When I do that, I get x equals 13. And when I subtract 9 from this one, I get x equals negative 31. When I plug both of these values back in for x, add 9 to them, and then square them, I end up with 484. All right, our next equation is, once again, a little different. This time we have x squared multiplied by 4. If you were graphing y equals 4 times x squared, the 4 is the amplitude. It makes the graph 4 times taller, right, in both directions. Taller and shorter, I guess. So basically, we're tackling this the same way we do other equations. We're getting x squared by itself, which means our first step is to divide by 4. Then we end up with x squared equals 144. And now this is when we unsquare or take the square root of both sides. So I'm going to take the square root of the left and the right. When I do that, I get x equals, remember to put that plus or minus here to account for the symmetrical nature of quadratic functions, plus or minus 12. That means when x is positive 12 and when x is negative 12, we have a solution to this problem. Make sure to plug 12 and negative 12 in for x to double check your answer. All right, similar to the last equation, I'm going to notice there's some negative signs. Let's see if that matters. So I'm getting x squared by itself, so I'm dividing by negative 3 on both sides. That gives me x squared on one side, and two negatives make a positive on this side, so I end up with 121. So as per usual, I'm going to take the square root of both sides because I'm trying to get x by itself. When I do that, I get x equals plus or minus 11. That means 11 and negative 11 are a solution for this equation. All right, our next problem is negative 5x squared equals 125. Straight away, I'm noticing that I have one negative. So that might be a problem for us moving forward, but let's go ahead and attempt to solve this. We're going to get x squared by itself as a first step. So to do that, we divide by negative 5 on both sides. When I do that, I end up with x squared equals negative 25. So we have a problem. There is not a number that I can put in for x that's negative or that's positive that when squared is going to give a negative number. Every single number squared is either 0, right? 0 squared is 0, or it's a positive number. So there is no real solution to this problem. There is a complex solution that involves the number I, but that's for a later video. So this one doesn't have this problem doesn't have real solutions. All right, now let's put all of these different types of problems together into one and solve a challenging quadratics equation. This is our most complicated problem to date. So our goal to keep in mind is that we are trying to get initially that x plus 1 quantity squared by itself. Then we are going to do the square rooting to get x by itself. So we've got to get rid of the 3 and the 2 before we can even begin to think about square rooting. And we're going to do that by following the order of operations backwards. And it's backwards because we have an equation. I'm going to start by dividing my equation into a left side and a right side to make sure that whatever we do to one side, we're actually doing to the other side. So I'm going to start using PEMDAS backwards, which is our abbreviation for order of operations. That means addition and subtraction. So I'm going to start by subtracting 2 from both sides. When I do that, I'm left with 3 times the quantity x plus 1 squared equals 300. All right, then on to my next step. I need to get this 3. I can't distribute this into the parentheses because of the square right here. So that means I need to get it off of this side into the other side. So I'm going to do the opposite of multiplying, which is dividing by 3 on both sides. And when I do that, I'm left with x plus 1 quantity squared equals 100. And now we are going to go ahead and take the square root of both sides to enable us to isolate x. And when I do that, I end up with x plus 1 on the left side. And since I'm the one that did the square rooting, I have to put a plus or minus 10 on this side. Now, at this point, we have some options for how we want to proceed. So over here, I'm going to do the way that I'm going to write it the way you can do it if you are trying to do it in your head. So I'm going to rewrite this. And then I could subtract 1 from both sides and end up with negative 1 plus or minus 10. We'll come back to this 1 in just a second, and I'll walk through how we do that mentally in just a moment. But before we do that, I'm going to go ahead and divide this into 2 equations. We have x plus 1 equals 10 and x plus 1 equals negative 10. So we're going to solve the left equation first, and we do that by subtracting 1 on both sides. When we do that, we are left with x on the left side and 9 on the right side, so that's one solution. We're going to subtract 1 from this side as this equation as well. When we do that, it's negative 10 minus 1, which gives us negative 11. So these are the 2 solutions that make our equation true. Now, if we didn't want to write all of this out, because some of us do not enjoy writing things out, we can do this in our head, and here's how we would do it. We would say negative 1 plus 10 is 9, and negative 1 minus 10 is negative 11. You see, you get the exact same solutions. Now, I urge you to check your answers here. So I'm going to go ahead, and everywhere I see x, I'm going to substitute 9 in initially. And then I'm going to do the same thing with negative 11. And what's going to happen is when I do this, I'm going to get 302 out here. And I'm going to get 302 out here. Now, I'm going to talk through how I did that in just a second. So remember, we have got to do PEMDAS going forward because we're only working one side of the equation, which means it's technically an expression. So we do it's in the parentheses first. Negative 11 plus 1 is negative 10, and we square it. That gives us 100. Now we go to multiplication and division. 100 times 3 is 300, plus 2 gives us 302. You're going to notice what's inside the parenthesis gives you 10 and negative 10 respectively. When you square those, you get the exact same value of 100. You can also just pop those in your calculator, and you'll get 302 out very quickly as well. It's our last problem in this problem set, and boy, do I see a lot of negatives. That's all right. Let's go ahead and get started. I'm going to start by dividing my equation into 2 sides, the left side and the right side, because we're going to be moving a lot of things from one side to another. So let's go ahead and get started. Remember, we're doing order of operation backwards because we're trying first to get x minus 5 quantity squared by itself so that we can square root it and then ultimately get x isolated on its own side. So we're going to start with any addition and subtraction. So I'm going to subtract 7 from both sides. When I do that, I'm left with negative 4 times the quantity x minus 5 squared equals negative 256. All right, now my next step is to divide by negative 4, right? Because I'm still trying to get just this part by itself. When I do that, I get x minus 5 squared equals negative, not negative, positive, because 2 negatives make a positive 64. All right, that's great. So now that I have my parenthesis raised to the power of 2 by itself, I can square root both sides to get rid of that square. And that unlocks the x, which is our goal. And that gives me plus or minus 8. All right, now I am going to go ahead and I'm just going to show this one way since I've shown it both ways multiple times. I'm going to add 5 to both sides. When I do that, I get x equals 5 plus 8 as one equation and 5 minus 8 as the second. Remember, we have to set up two equations because quadratics are symmetrical and we get two symmetrical values for x, distance from the line of symmetry, and they share the same y value. So in this case, x is 13 when we add those together. And in this case, x is -3. So we could plug these back into our main equation right here, and we should get -249 out when we do that. You should always check your answer, but I've already checked this, so I know this works. So that is how you that is how you solve for the solutions to this equation. Thank you for joining me and working through so many equations. Make sure to subscribe so you don't miss a video. Till next time, remember, you've got this.